what is the price of ignoring Bayes? Here we want to give a very brief treatment to the difference between Bayesian and frequentist frameworks. We want to talk about something that we haven't really talked about so far, because all of the assumptions with all of the tests is this classical frequentist assumption. We are making assertions about what's happening in the real world, but they're kind of based off of our own personal judgment of what an adequate threshold is and what an adequate p-value is. And it may be the case that we want to be a little bit more specific about what our beliefs are, and we want to encode our beliefs. We may not be able to just make it with p-values. In fact, p-values are quite controversial, and the Bayesian approach is a much more popular approach these days than this classical approach. The classical approach is very powerful, and it's actually fairly simple. You can see we can hand construct most of these ourselves without even having to reach for stats, models, or SciPy. But just as a reminder, every time we were doing some sort of hypothesis testing within the classical approach, we were first deciding on a null hypothesis that we were looking to accept or reject. It was usually the inverse of the thing that we kind of want to have happen. So it's usually, if we want something to have had an effect, it's usually, oh, there was no effect. Paired with that null hypothesis was an alternative hypothesis. No effect is a null hypothesis. Some effect is an alternative hypothesis. Didn't make it better, did make it better. Or, sorry, I shouldn't say didn't make it better. Didn't make it better or stayed the same. So that's, made it worse or stayed the same, and did make it better. We picked some alpha value, some significance criterion. Where do we pick it? We saw whatever we could get away with. We picked something that felt good. There's a little bit of fuzziness there. And then we picked our p-value, and we used that to make an assertion about the real world, the p-value being the probability that something is true in the real population given the data that we see. And based off of that, we accept or reject our null hypothesis, which leads us towards, via proof of contradiction, to our alternative hypothesis. But in the Bayesian approach, in the alternative approach, we start with the laws of probability, and we start with Bayes' theorem. Bayes' theorem expresses itself in terms of conditional probabilities. What is the probability? And by the way, we're not going to talk about the null hypothesis in Bayes' theorem here. We'll talk about it in a moment. But what's the probability that the alternative hypothesis, the thing we were actually looking for, is true given the data that we see? Well, it's equal to, via the laws of probability, the probability that the data occurs given that the alternative hypothesis is correct times the probability of the alternative hypothesis, which is one giant unstated assumption of our classical approach, divided by the overall probability that we see the data that we see. Where the overall probability of the data that we see, it is the probability that we see that data given the null hypothesis, scaled by the null hypothesis, times the probability we see it given the alternative hypothesis, scaled by the alternative hypothesis. With Bayes' theorem, we're explicating things like our prior probabilities. There is still some gut feeling that we have to provide, but we're more explicit about saying this is a prior probability that we're providing. We're trying to compute exactly this posterior probability, what we want to determine, which is the probability that our hypothesis is correct given the evidence that we see for it. We have to assume, and we have to provide, and we may even disagree about what the probability that the hypothesis is correct in general. Is it really probable that the hypothesis is correct? Is it like 50%? Is it very improbable that probability was correct? Given that, we can scale it by the evidence that we see, and we can determine what the posterior probability, what the probability that the hypothesis is correct is. In the Bayesian approach, we have to provide the prior probabilities, and we can disagree about them. Sometimes people express Bayes' theorem in terms of Bayes' factor, which allows you to plug in your own prior probability. You may have even heard people say, maybe you should revisit your priors. Part of what we like about the Bayesian approach, the classical approach does not really give us, is the ability to be very explicit about our worldview and to express things like this alternative hypothesis and the null hypothesis in terms of our preconception about the world, plus some data, and what that allows us to conclude. And to be very explicit about our beliefs, not just making assumptions about what's happening in the world based off of some data that we see.